Hello, everyone. Thanks for being with us here today, and welcome to our session, Safely Delegate Your Cloud Operations with Self-Service Automation. I'm Dave Rubenstein, Editor-in-Chief of SD Times. And before we get started, I have just a couple of quick announcements. First, today's session will be followed by a live Q&A. So at any point during the conversation, you can go to the Questions tab in the control panel, type in your question, submit it, and we'll get to as many as time will allow. Secondly, this is being recorded and will be available on demand tomorrow on the sdtimes.com website. And finally, in the handouts tab in the control panel, there's some supplemental reading for you to download and refer back to as need be. Okay, so as we've been reporting in SD Times, running operations is not an easy job. Ops teams have to ensure excellent user experience, resolve incidents quickly, and help developers stay productive. Yet at the same time, there's also the need to maintain system security and keep downtime to a minimum. While advances in cloud computing have helped address some of these challenges, many organizations find it difficult to leverage the cloud at scale because of bottlenecks that form around repetitive tasks, such as developers having to wait for provisioning infrastructure. So despite having access to abundant cloud resources, these speed bumps often make it difficult to achieve team objectives. Joining me today to speak to this issue is Jesse Holdsworth. He's a senior solutions architect at the company called PagerDuty, which I'm sure you all know. So here to get us started is Jesse. Take it away.
All right, thanks everybody. So yeah, my name is Jesse Holdsworth. I'm a senior solutions consultant here at PagerDuty, focusing on the Runbook automation platform, and I'll be leading our discussion today. And so as we've covered, right, the topic of today's discussion is self-service in the public cloud. And I'm fairly certain that everyone here today is familiar with why the public cloud is such a major point of discussion. And it may sound obvious, right? The benefits or the potential benefits of the public cloud are vast. Beyond the obvious technical benefits of scalability and barrier to entry, which we refer to as accessibility, there's the more intangible benefits of business agility, meaning with the with the proper use of public cloud services, companies are now able to iterate faster and add features to their core products faster than ever before. But with a healthy dose of reality, we know that many of these benefits of the cloud come, they can come with some consequences. And the most obvious and perhaps the most talked about, I actually just saw an article about this in The Economist this week, is cost. And without the proper monitoring and controls in place, cloud costs can become untamable. And especially if certain usage patterns are not watched carefully early on, it can be really hard to kind of claw them back later on. These last two buckets here that I'll discuss are usually more within the context of monitoring and security, but they are really relevant when it comes to maximizing ROI in the cloud. And the first is architectural complexity. And this refers to the fact that applications are now made up of far more components than ever before, and typically span a greater geographical footprint. In my experience, this last bucket here is the least frequently discussed, and that's tooling sophistication and diversity. And what this is referring to is the fact that everything in the cloud can be defined as code. And in a way, that's what's great. That's what enables us to decouple from physical hardware and move fast and everything. But there is a downside to this, though. And that's the fact of the matter is that public cloud services are designed with developers and really technical folks in mind. And that and to a degree that makes sense, given that they're supposed to be the building blocks of modern applications and infrastructures. But the downside here is that in order to manage them, you need to have a certain level of technical expertise as well as a familiarity with the cloud services that are being used. In this picture over here on the right, we see a bit of cloud formation code, but this could easily be, Terraform or, Chef, Puppet, Jenkins, any other tooling that you use to, automate infrastructure. And this works for those that that really understand this code and that have really been trained on it. But what about the other teams that may heavily depend on resources running in the cloud that don't have these these really technical chops or level of access? And this actually tends to happen quite frequently. There may be users in customer service that need to get some information about a specific customer. And let's say the only way to retrieve that information is to query, our infrastructure or a database running in the cloud. Maybe it's an incident responder that needs to, restart a service or, redeploy a previous build to help resolve an incident, or maybe they just need some logs so that they can triage or diagnose something that's going wrong. Or even if somebody has the right technical skills, let's say I'm a developer that needs a snapshot of a database to, let's say, reproduce some certain behavior, but I don't have access to the environment where this database exists. Maybe it's a network configuration change to allow for connectivity to a new branch office that's opening. The list of use cases can go on and on, where operations and cloud teams are constantly just inundated with these types of requests. And this is what we see creating a serious bottleneck here. To make matters more complicated, our environments are always changing. And this means that, there are even fewer people throughout the organization that really genuinely understand the architecture of our services and our applications. And so even if best case scenario, let's say you were to give the right level of permissions to the right people via your cloud console or your CLI, you would still have a difficult time, since it's not in their wheelhouse to remember that, let's say, the shopping cart service is running in this namespace on this cluster, but it also depends on this RDS database and those S3 buckets and these API gateways, et cetera, et cetera. And tomorrow some of this could all change, right? And so this raises the question, how can we fully take advantage of the promises of the public cloud without creating these bottlenecks throughout the organization, especially since these bottlenecks typically involve those that are involved in building and delivering our company's products and bringing them to market. So we think that one critical piece to this puzzle is to provide the capabilities of the cloud in a secure interface that anyone can consume. And this means, allowing for our users to fulfill these tasks that utilize cloud services without the need to acquire these highly technical skills or tribal knowledge of architecture and dependencies. It can also mean that they can leverage the capabilities right from within the tools they're already using. These could be tools, like PagerDuty or ServiceNow or Jira, et cetera. And so, this is really where Rundeck fits in, right? We provide an interface for these technical experts, such as operations engineers and developers, We provide them an interface to define and maintain a set of standards by which others can access our secure internal operations. And I'll also mention that this model also lends itself to non-cloud operations as well. We're just focusing on cloud today because some of these patterns and bottlenecks are extra prevalent when using public cloud services. So once you have some use cases identified, the first step is to work with your domain experts to understand their workflows and what it is they're doing to fulfill these sorts of requests, right? What tools are they using today? Do they already have scripts written? What order are they executing tasks in? Are there handoffs, where somebody does steps 1 through 5, and then they hand off to somebody else to do steps 6, 7, and 8, for example. And once you really understand how these processes are being executed on, the next step is to take this knowledge and really codify these workflows into self-service jobs. And here at Rundeck, we help customers do this all the time, and our platform basically gives folks an easy button that they can push as needed. And this makes your workflows more secure, more auditable, and easier to run. Now, when getting started, it can be overwhelming to think about just where do we begin, right? And to try to foresee all the hurdles in providing a self-service program across your teams. And so there's a few pieces of advice we have here that we'd recommend to anyone that's embarking on a journey like this. And first and foremost, this sort of automation should be the kind that is used more than once, right? Like we're never going to automate literally everything that we do in our lives here, right? So it's automation isn't usually a great candidate for like a one-time sort of task, like a one-time data transfer. A rule of thumb we hear from a lot of self-service automation teams is that if it's something we do more than once, it goes into Rundeck. And so, these high value tasks are usually things that are being executed fairly regularly. And the next piece here is really critical, and it's rare that you are coming you're embarking on a journey like this from a state of zero automation. Usually we see folks have already got scripts written, they're already using some domain specific tools, right? Like maybe we're using Terraform to build out provision infrastructure, then we're using Ansible to kind of get things installed and patched the way we want it, et cetera. Maybe we've got some Python, some shell scripts that kind of act as some glue here and there. Whatever self-service automation platform you choose, it's important to keep in mind what automation you already have to make sure that it's going to fit in really well, so that you don't have to reinvent the wheel and start all over from square one. And last but not least is this may be obvious, right? But when we're talking about self-service, we really need to take our users into account here. So if you want users to be able to leverage these capabilities without them having to interrupt the automation authors every time they have to use it, the interface has to be really flexible and not make assumptions about their technical expertise or their tribal knowledge here. One way to properly plan for a journey like this is through a phased approach. It kind of, as you would like an evolution, and the image here outlines some characteristics of each maturity stage. So we can kind of see where we're at today and understand what the next phase looks like. So over on the left we've got manual, right? And in this stage we've got a lot of workflows that require a lot of human involvement. Next would be reactive. Here at this stage, there's more automation than there is manual workflows, but there's still a lack of standardization in operational frameworks. Kind of in the blue here would be responsive. Once you have some frameworks in place, then it's easier to move into delegation, meaning providing the automation as self-service. And again, this can be done through a dedicated interface like Rundeck or through tools that you're already using today. Again, these could be tools like PagerDuty, ServiceNow, Jira, etc. And then finally, proactive. And we talk a lot about non-emergency use cases in this presentation, but in this last phase of the maturity model is around event-driven automation. In this phase, organizations are really reaping the benefits of better maturity as context-specific diagnostics and mitigation are automatically being triggered when an incident hits. And so this is really the end result here, right? For tasks that tend to be self-service or more like change requests, this improves the turnaround time and reduces the interruptions to our domain experts. And for incidents, this is, this reduces the time to restore service, performance, and availability, and it reduces the number of escalations. Sometimes to the same domain experts that we talked about in the self-service world. And so now I'm happy to move on to the demo, which is I'm sure what you all have been waiting for. We're having some technical challenges today with some of our demo environments, so I'm going to play a recording here instead of going through it live.
All right. So here's the Rundeck user interface, and we're going to start by looking at an example of self-service automation for an operation that would typically require, at least one domain expert in the cloud or in technical operations. And what we see here is our list of Rundeck jobs in various jobs groups. I can expand all of these, but I'll go ahead and look at this example to snapshot a database for developers, and this database is running in AWS. So we're going to snapshot this database, and we're actually going to move it to a VM that's going to be provisioned in Azure. So this is a Rundeck job that spans both AWS and Azure. And the first thing that you'll see here is this interface, again, is not all that technical. It's not making any assumptions about how much I know where this database is running and how I'm going to transfer it from point A to point B. But we'll go ahead and start executing this because it takes a couple minutes to provision that new VM. So this will be a production snapshot for dev. I can optionally add, certain services or scripting languages on here for whatever the purpose might be. I can choose how many rows of the database I want to snapshot, and which Azure resource group I want to provision my new VM in, and then upload this snapshot to. And the point being here is that I've provided a very simplistic and guardrailed interface for this end user. Again, maybe this end user is actually someone in marketing that needs a snapshot of aggregate customer data or user data to run some business analytics on. And we don't want to make any assumptions that marketing person has the technical domain expertise of a cloud operations engineer. So we'll go ahead and start running this. And what I'll show here is the workflow view first. And so what this is showing is that these first two steps of this workflow, and each of these steps is comprised of multiple other steps that I'll show in a second. These first two steps are actually running in parallel, right? So we're snapshotting this database running on an EC2 in AWS, and we pushed it to Azure Blob Storage. At the same time, we were starting the provisioning of the VM in Azure. And once that provisioning of the VM is complete, then we can go ahead and actually push the database snapshot to that VM. And so this type of parallel and sequential job execution is native to the Rundeck platform. And when we go back to our nodes view, what you can see are all of the steps that are involved in this operation. And the fact that these steps comprise a mix of Rundeck out-of-the-box plugins for the public cloud, as well as harnessing existing automation. And we'll show that in a second. So we're going to let this continue to run. We'll come back to it when it's finished. In the meantime, we're going to toggle over to a second example of this self-service automation in an interface that you are all likely very familiar with and that your users use day in and day out, and that's PagerDuty. So if we're in PagerDuty and an incident has occurred triggered by an alert in your monitoring. So for example, you have New Relic or Datadog that's triggered an alert. The incident in PagerDuty and the alert coming in is only as good as the monitoring signal or the monitoring rule that triggered that alert. In this case, it's a health check for our payment service pod, and so it includes information about the pod, but it's fairly rudimentary in terms of its level of detail. And what we want to do is replicate what the end user, the first responder, would do to better diagnose what the issue is. And what we can see is in the timeline here, this incident, when it was triggered, actually invoked a Rundeck job to go and fetch pod logs, the logs on this payment service pod, and thereby point the first responder to either the root cause, and they can start troubleshooting, or help them better triangulate, thereby helping them know who to escalate to. Taking this one step further, what we are able to do with PagerDuty and Rundeck is give that self-service mechanism as a way to remediate right from within PagerDuty, either in the web GUI or through the mobile app. And so this button that you see here, this what we call a custom incident action, would also appear in the mobile app. And what this allows me to do is redeploy the payment service pod, the payment service in Kubernetes, without this third-party API dependency, which is a fail-safe mechanism to potentially restore service. And you can think of these types of actions that you would see here as a simple restart or a rollback or a failover, those types of actions that you would want some human touch. But again, your responders, they might not be the cloud domain experts or Kubernetes experts. And so providing them this safe guardrail mechanism through PagerDuty lowers that barrier to entry for them to be able to take action. So I'll go ahead and invoke that, and we will see on the timeline that it shows that this incident action was invoked by me. And in a second, we will see that this Rundeck job has redeployed the pod and provided the Kubernetes deployment YAML for this new service. And what we see is that this environment variable for third-party APIs now says no. So we've cut that dependency on this third-party service. And in a minute, this will self-heal or self-resolve because the New Relic alert will clear. So we can come back to that in a minute. Back in Rundeck from the Azure job, the DB snapshot job, what we'll take a look at is the fact that this Rundeck job is comprised of actually 3 other Rundeck jobs. So we've made it easy to author automation in Rundeck by building these building blocks of automation rather than requiring an automation author to rebuild and reinvent the wheel every time there's a need to, for example, snapshot a database. But if we look at one of these jobs, the critical piece here is that what a Rundeck job is comprised of is the job steps And as mentioned before, the Rundeck philosophy is to be able to provide you with our native out-of-the-box plugins and integrations. So in this case, we have an out-of-the-box plugin integration for Azure, and we also provide integrations for AWS and other public cloud providers. But we also make it easy to wrap around existing automation, in this case, just a command at the command line. But this could very well be wrapping around a Python script or an Ansible playbook or a Terraform plan, and thereby, again, not requiring you to author this automation from scratch. And then the last piece I'll show here is that Kubernetes job that toggle the K8's service dependency on third-party APIs. Similarly, what we can see is that I can invoke this from Rundeck. In the demo that we just showed, it was invoked from PagerDuty. But what we'll show here is a very similar job definition in that we're providing out-of-the-box integrations for managing your Kubernetes cluster and services running in Kubernetes, but also, again, the ability to say, just harness the kubectl commands at the command line, because maybe those are the playbooks that you have today, which is just using the CLI interfaces. And so with that, we'll switch back here and want to thank everyone for attending, and I'll take the questions that have now been posted into the Q&A.
All right, thank you very much. We'll get right into the questions. Again, I remind people, if you have any questions, submit them now, and we'll, as I said, get to as many as time allows. But here's the first one, Jesse. How is Rundeck communicating with our infrastructure and services, and how is that communication secured?
Yeah, so Rundeck is going to be using the native protocols and methods of communicating that we as engineers would be using if we were doing things manually. Oftentimes in the Unix world, that basically means SSH. In the Windows world, that oftentimes will mean PowerShell or WinRM. And then if you're using tools that interact via APIs or webhooks, it would be APIs and webhooks that are again going to be secured exactly the same way that they would if these tasks were being done by humans here.
Mm-hmm. Excellent. Okay, the next question is, how did Rundeck know about which pods to target, and does this work for VMs as well?
Yep. So Rundeck can be configured to basically listen to certain parts of your infrastructure, so that we always have an up-to-date inventory of which VMs, which pods, containers, etc., exist out there, so that as your environment fluctuates, we'll always know what's online and what's healthy and such.
Okay. The next one is, if we're already using a tool like Ansible for this sort of automation, does Rundeck work with these types of tools?
Yeah, absolutely. So again, one of the things I mentioned in the talk was that it's usually pretty rare that folks are starting from a place of zero automation already. If you're already using whether it's Ansible or Terraform or Chef, Puppet, etc., that's great. You've already started to take the leap into automation. Where a lot of times folks need to kind of take their, let's say, their Ansible to the next level is, we come across a bottleneck where, especially for non-technical folks in our companies, they oftentimes need something done via Ansible, but they don't know how to use Ansible. They might not even know what Ansible does or what its purpose is. And so by basically wrapping Rundeck around some of these more technical, complicated workflows here, we can basically expose, let's say, your Ansible jobs to, folks that don't have all of that Ansible training that you might have, so that they don't have to interrupt you anymore. So you can finally get some work done, hopefully.
Mm-hmm. Great. And of course, the best question, which I saved for last, somebody wants to know, won't I be automating myself out of a job?
Yeah. Um, in all honesty, that really, I don't see that happen at all in any of my engagements with customers. Again, usually what I oftentimes see is that folks are kind of drowning in these repetitive tasks, and
Mm-hmm.
that's preventing them from getting to any real meaningful work. If anybody's read the Phoenix Project or the Unicorn Project, if you think of that one character, Brent, right? Brent was always the one person that could, fix any issue, but because of that, he was never able to really do any value-adding work because he was always in firefighting mode here. So,
Yeah.
the more we can get help folks get away from these really repetitive tasks, the more time we'll be able to spend on, making our products and services, that much better and bringing more, better features to market, et cetera.
Mm-hmm. Sounds good. All right. Well, Jesse Holdsworth, thank you so much for a great presentation today. I would also like to thank PagerDuty for sponsoring and for providing the Rundeck demo. And of course, I'd like to thank all our attendees for being with us today, and those of you who are going to be listening on demand. Thank you so much for your time. Once again, I'm Dave Rubenstein, Editor-in-Chief of SD Times. Until next time, so long for now.